Hello everyone. Today our topics Calcutta University year 2021 question paper CC3 discussion. Okay. So first question given that let A equals to closed interval 0 1 and B equals to 1 by half such that n belongs to natural number. Then A minus B is open set, closed set, neither open nor closed, or closed set. Which one option is correct? So first of all, here given that A equals to closed interval 0 1 and B set given that 1 by n such that n belongs to natural number. So this type of elements are 1 1 by 2 1 by 3 1 by 4 1 by 5 so on. That is B set is countable infinite set. Okay, now we find A minus B, that is closed interval 0 1 minus of 1 1 by 2 1 by 3 1 by 4 1 by 5 so on. So here we easily see that 0 1 1 by 2 1 by 3 1 by 4 1 by 5 subtract but neglect from closed interval 0 1. So obviously we conclude that this half, one open interval, one third half, this type of interval exists. That is union of n equals to 1 to infinity 1 by n plus 1 1 by n. This type of open interval exists if we discard 1 1 by 2 1 by 3 1 by 4 1 by 5 so on. So we also know that open set, union of open set is also open set. So definitely here the first option is correct. So I hope it is clear. Second question given that let B equals to 1 by twice n plus 1 by 3m such that mn belongs to natural number, then one third is which option is correct? A limit point of the set but not an element of the set, not a limit point the set but an element of the set, both an element and limit point of the set, neither an element nor a limit point of the set. Now this type of question we solve if fixed m equals to 1. Then B equals to, we can write half plus 1 by 3 plus 1 by 4 plus 1 third plus 1 by 6 plus 1 third so on. Okay. So there nth term obviously 1 by 2n plus 1 third form if we consider m equals to 1. Okay. Then we convert limit n tends to infinity an. This give 1 by n. So 1 by m 1 third is a limit point of the set. But definitely we say that 1 third it does not belongs to of above set. So 1 third is a limit point but not an element of the set. So option 1 is correct. I hope it is clear. Next question. If A and B are bounded subset of R such that supremum of A less equals to infimum of B, then which option is correct? So this type of question we solved if we consider A equals to open interval 0 1 and B equals to open interval 2 3. So obviously we see that supremum of A equals to 1 and here infimum of B equals to 2, and also satisfy this condition that supremum of A less equals to infimum of B. Therefore we see that A and B are disjoint. Definitely here A set is open interval 0 1 and B set is open interval 2 3. So A intersection B is equal to null set. So here option second is correct. So I hope it is clear. Fourth question given that the set T equals to x1 x2 x3 xn such that x1 x2 xn belongs to 1 3 5 7 9. So definitely we say that here 1 3 5 7 9 is a countable and finite number. So definitely T we consider countable finite. So definitely here option second is correct. Five number question says that which of the following statement is true. Okay. So first statement says that every bounded set has a limit point. Okay. So if we consider minus 1 whole to the power n which is bounded but not exactly unique limit point. Here if n is even, so this type of 1 and n is odd, this type of minus 1. This is a auxiliary sequence. So it's not a exactly unit exist, a limit exists. So first option is incorrect. Second here said that every infinite set has a limit. So if we consider a n equals to n and limit n tends to infinity, a n is equal to infinity, not limit point. So second option is also discard. Third option says that every bounded infinite set has a limit interior point, and fourth option says that every uncountable set has a limit point. If we consider an uncountable set, that is R is an uncountable set. Uncountable set means not countable, that is R. Okay, R Q, it is R minus Q, irrational number, it is uncountable. This is not a countable, that is uncountable. So R is an uncountable set and its limit does not exist, so it is also incorrect. So obviously 1, 3rd and 4th is correct, so definitely option 3 is correct. Okay, I hope it is clear. Next question, if 0 less than x less than 2021, then limit of x to the power n plus 1 plus 2021 whole to the power n plus 1 by x to the power n plus 2021 to the power n is which option is correct? So this problem we can write that x by 2021 whole to the power n plus 1 by x by 2021 whole to the power n plus 1, and here 2021 extra divide, so multiply 2021. Okay, since x less than 2021, so definitely x divided by 2021 less than 1. Also we know that limit of n tends to infinity r to the power n is equal to 0 if r exists minus 1 to 1. So obviously here we say that here is type of x is this type and which is less than 1, and this type goes to 0 if this is less than 1. So definitely it's less than 1 and limit of this type is equal to 0. So we put the value, we get 2021. So 2021 where exists? Option 3 exists, so option 3 is correct. Second question, xn equals to 1 plus sine n square plus 1 pi plus cos to the power nq minus 1 pi by n plus 1, then limit of supremum of xn is which option is correct? So we know that sine of n square plus 1 pi is a bounded function, and mod of sine of n square plus 1 pi is equals to 1. Also cos of n square minus 1 pi is also bounded function. So definitely this is maximum value gives 1. Okay. So we also know that, so mod of xn is equals to 3 by n plus 1. We can write that. So now limit of n tends to infinity 3 by n plus 1. This goes to 0. So definitely, so this also goes to 0. So which option is correct? Option 4 is correct. Another question says that identify the incorrect statement from the following statement. Every convergence sequence is bounded, definitely it's 2. Here say that incorrect option choose, so first option is discard. Every bounded sequence had at least one subsequential limit, it's also be correct, so it is discard. Unbounded sequence cannot have any subsequence, here cannot have means says that. So if we consider, take the sequence 0, 1, 0, 2, 0, 3, 0, 4, this is the unbounded sequence if we consider, and its subsequence we say 0, 0, 0, 0 is a subsequence of this sequence, so 0, 0, 0, 0 is converged to 0, and this is also convergent. Here say that not convergent, so option 3 is correct. I hope it is clear. Next question, let an be the sequence of positive integer and bounded by a positive integer k, then the series summation of n equals to 1 to infinity an by k plus 1 whole to the power n must convergent, must divergent, may be convergent, may be divergent. So here an is a positive integer and bounded. So here we consider an equals to n. So un equals to an by k plus 1 whole to the power n we let. Okay. Now by ratio test, limit of n tends to infinity un plus 1 by un. This gives up 1 by k plus 1. So k is a positive integer. So 1 by k plus 1 obviously less than 1. Okay. So less than 1. So by ratio test, summation of un must be convergent. Okay. So option 1 is correct. I hope it is clear. Next question, the series summation of n equals to 1 to infinity 2n square by 1 plus n square, convergent converges to 0, converges to 1, divergent converges to 2. Using this problem we solve using limit form of comparison test. We easily solve it. Let un equals to 2n square by 1 plus n square. Now limit of and vn equals to 1. So now limit of n tends to infinity un by vn, we get 2. So if we find a non-zero real number, then summation of vn is convergent, so un is convergent. Summation of un is divergent, so summation of vn divergence, so summation of un is also divergent. Here we see that summation of vn is equal to summation of 1, that is 1, which is divergent, so obviously summation of un is also divergent. So here option 3 is correct. I hope all problem are clear. Thank you.